Welcome back to a new episode of Prep Set Go, and we'll be continuing our look at surface preparation, and today we are going to talk about substrate porosity. So what it means, why it's important, and how this can impact the application of our surface finish. So let's get started. So first off, what is surface porosity? Well, porosity relates to the absorbency or permeability of a surface to moisture and gases. So highly porous surfaces readily absorb moisture and can include surfaces like screeds, render, or plasterboard, to name a few. While non-porous substrates don't readily absorb moisture and can include things like metals, plastics, glass, and ceramics. Now, concrete can fall into both categories, and its porosity is determined by a number of factors, including the use of densifiers in the mix, the strength of the mix, and how the concrete is finished or floated. So with steel floats and power finishes, they produce a smoother, more burnished finish. So why is assessing surface porosity important when it comes to bonding a finish or a coating? Now for that, we need to look at how the surface porosity can actually directly affect our overlaid coating. It can determine the suitability of a surface for applying a coating or finish over, and it can determine the type and level of surface preparation that may be needed. So let's look at how the porosity of a surface can directly affect our overlaid system. So, number one, adhesion. Porous surfaces are typically easier to bond to because of the open surface profile. On the flip side, however, for liquid coatings, including waterproof membranes, they're more susceptible to pinholing when applied over a porous surface. Now, this is due to the rapid absorption and drawing down of the moisture contained in the material into the actual substrate. Pores of concrete contain air and become trapped when the coating is applied over it. The trapped air then tries to escape, pushing up against the coating and then creating these small pinholes. Number three, coverage rates. Now, porous surfaces will generally require greater coverage of a coating or an adhesive. And drying times. Now, liquid coatings and cement-based adhesives will dry much faster over a porous surfaces as the moisture is drawn out at a much faster rate. Now, let's look at non-porous surfaces. Number one, adhesion. Now, non-porous surfaces are generally more challenging to adhere to. Coatings or adhesives, if unsuited for use over these surfaces, may eventually dry, but not achieve any meaningful bond to the surface, to the point where they can actually just be peeled up cleanly from a surface. Now, two, surface prep. Now, depending on what's being applied, non-porous surfaces can require a greater level of preparation and can include things like mechanical treatment, grinding, to open up the pores and roughen the surface. Number three, drying. Liquid coatings would take longer to dry over less porous surfaces as the rate of absorbency is reduced. Now, ultimately, the suitability of a surface for the application of a coating or finish based on its porosity is determined by the manufacturer of the system to be applied. So before starting any application, it's crucial that you read the manufacturer's recommendations and user instructions found on the product TDS or packaging. So the obvious question, how do you determine the porosity of a surface? Now, the standard ASTM F3191 establishes a simple method for determining surface porosity by way of a water droplet test. And the method is as follows. So substrates must be clean and free of dust and other surface contaminants. Place a single drop of clean water onto the surface. And the porosity of the substrate is then determined by how long the water takes to absorb into the substrate. So according to the standards guidelines, less than 1 minute is a porous substrate, and more than 1 minute is a non-porous substrate. Now, surface preparation. As mentioned earlier, the relative preparation required for porous and non-porous surfaces is determined by the manufacturer of the system to be applied. Now, over porous surfaces, for liquid coatings and waterproof membranes, a primer would typically be required. Now, the primer will soak into the surface and then displace the trapped air, in turn reducing the likelihood of pinholing. The primer may also help regulate drying by preventing the rapid absorption and drawing down of moisture from the coating or adhesive. The primer can also help improve coverage by preventing the overabsorption of moisture into that surface. Now, for non-porous surfaces, primers can also be used to provide a compatible surface for overlaid coatings and finishes and enable to bond to a surface that wouldn't normally be possible. Alternatively, mechanical preparation may be required to provide the necessary key and can include things like grinding or shot blasting. So thanks again for joining us for this episode of Prep Set Go. We hope you've taken something away from it. And of course, if you have any questions, comments or feedback, we'd love to hear from you. Until next time, goodbye.